In this lesson, we're going to 8.3.2. We're going to compare proportional graphs. So in a proportional graph, if you remember from last lesson, I always started at 0, 0 and continued in a straight line. So the change was the same over time. If something changed in 1 week, it grew 2 inches. Every week it would grow 2 inches. So 2 inches would be 4, 4 inches, 3 inches would be 6, 4 inches would be 8. And if you remember, what we did was we said our equation looked like this: y equals whatever our constant of proportionality, which now we know as our slope. Constant of proportionality last year was k, so now we're going to know it as the slope. Y equals, instead of slope, we're going to write m. M just represents how it's moving over time, and x. So y equals mx. So we're going to look at a couple of different ones. We're going to say, okay, well, I'm going to write it down a couple of equations here. And I want you to think about which one's changing faster over time. So here's my first one. Y equals 3x and y equals 4x. So if I were to look at these and say, okay, so just imagine to myself, this one is changing 3, but what does 3 mean? Well, it really means that it's 3 over 1. This one's changing 4 over 1, whether that be feet in a minute, whether that be inches in a week, whether that be dollars for every video. That's what it means. So let's look at what these two graphs would look like. So in the first one, I said, look, y equals 3x. So we're going to start here 0 because so far at this starting point, nothing's moved, nothing's changed. So it's always 0, 0. So that's why we always start at 0. Well, this one says go up 3 and over 1. Cool. Up 3 over 1. So it changes 3 times for every 1 time. So that means 6 for every 2, would mean 9 for every 3, would mean 12 for every 4, and so on. And it would continue to grow at the same rate. The next one says y equals 4x. So in this case, we're going to go back down here, and we're going to say, okay, we know we always start at 0, 0, but this time it's going to go up 1, 2, 3, 4 over 1. Then up 1, 1, 2, 3, 4, and over 1. Up 1, 2, 3, 4, and over 1. And so on and so forth. So which one is changing faster? Well, when my graph looks like this, when I'm talking about independent and dependent variables, which one determines the other? This is always my x, this is always my y. So like we said last week, the time determined how many inches it grew. Well, in this case, the time determines how many inches. This plant grows at 3 inches every week. This plant grows at 4 inches every week. Let's try a couple more. Let me get rid of all this stuff. And we're going to go, this time we're going to try this. We're going to go y equals 3x, which is exactly what 3 over 1x, which is exactly what we talked about before, but we're going to use the inverse of 3. Y equals 1 over 3. Inverse is always the opposite. So let's look at what these two graphs look like. We always start at 0, 0. We know the 3 over 1 look like this, but this time we're going to compare it to the 1 over 3. Y equals up 1 and over 1, 2, 3. Looking at these two graphs, Which one's changing faster? In this case, it's the steepness of the graph. Last week we saw the turtle and the hare, but the steepness of the graph didn't determine it. It was actually flipped on its side. How far they went was on the bottom. What time it took them was on the side. So it's always important to read what it says on the sides of the graphs.